right, good morning, students. Today we are going to be talking about right triangle trigonometry. We're on lesson 9.4, and we're going to be doing right triangle trigonometry. So you can get out a page of notes. You can probably write this on page 297 if you choose. And we're going to be talking about right triangles. All right. The first we're going to do is we're going to do a basic, kind of get some basic definitions down. This symbol, I believe it's called theta. This symbol means angle. That symbol means angle. So here's your three basic right triangle trigonometry is sine, cosine, and tangent. Sine, cosine, and tangent. So what we have here is we have a right triangle, okay? And why we need to know this angle is because these are going to be different depending on where our angle is. If the angle we're talking about is here, or if the angle is here. So let's say that the angle we're talking about is here. So there's our angle sign. So I'm talking about this one. Now, if this is the angle we're dealing with, the side next to it, well, this is the hypotenuse. Regardless, this is the hypotenuse. Right? For any triangle, we have the side that's opposite the 90, or we have the long side, and that's the hypotenuse. Sorry, we've got some wild boar running in Discovery. So that's the hypotenuse. The longest side is the hypotenuse. Now, if this is our angle, this side length is going to be adjacent, and then this side length is opposite. Again, that's if this is our angle, because I've labeled it theta, I think is what it's called. So the sine of this angle has to do with adjacent, opposite, and hypotenuse. All right. So what is sine? Well, sine is opposite over hypotenuse. Okay. What's cosine? Cosine is the adjacent angle over the hypotenuse. Adjacent over hypotenuse. So we have the cosine of this angle is the adjacent over the hypotenuse. And then the tangent is the opposite side over the adjacent. So tangent of this is going to be opposite over adjacent. Okay, so there's your three. There's your basic. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, now what if we changed and we did this angle right here, angle X? Well, then all of a sudden, this is still hypotenuse, but then this becomes opposite, and this is adjacent. Right, so it depends on where the angle is, because here, from this angle, this is the opposite side, and this is the adjacent side. So just make sure you know where your angle is, so you know which one's opposite and which one's adjacent. Okay? So sine, cosine, and tangent is relative to the angle chosen. It's relative to the angle chosen. It'll never be this. It'll never be the 90. It'll always be one of these two. But sine, cosine, and tangent is relevant to sine, cosine, and tangent are relative relative to the angle chosen. Okay? All right. Now, let's see how this plays out. Well, let's take, actually, I'll just roll it down. Let's do this triangle right here. And let's say we have 3, 4, and 5. So there's our angles, 3, 4, and 5. So let's do sine of, let's call this A, B, C. So let's say sine A. So sine A, if I look up here, so here's angle A. So this is my angle that I'm relative to. I go up here and I see sine is opposite over hypotenuse. So if this is my angle, this would be opposite, and this would be adjacent, and this would be hypotenuse. Because this is my angle, this is one adjacent to it, this is one opposite. So sine is opposite over hypotenuse. Opposite over hypotenuse. There it is. Now cosine of A, cosine is adjacent over hypotenuse. So adjacent over hypotenuse, 3 over 5. And then tangent A is opposite over adjacent. So opposite over adjacent, 4/3. So there you have sine, cosine, and tangent for this triangle. Now what if I took it from B? So what if I had sine B? So from this one, well, sine is opposite over hypotenuse. So opposite is 3 over hypotenuse is 5. What if I had cosine? Cosine B, so cosine from here. Well, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And then tangent. Tangent B. So tangent is opposite over adjacent. So opposite over adjacent. All right. As you'll notice, tangent for one triangle is the reciprocal of tangent from the other triangle. Okay. That's the basics. Now, let's go in and see how we can solve some problems. Let's say, and this you definitely need to pay attention to, because if you don't have this lesson will be super hard. So we have A, B, C, and you have angle 36 degrees, you have 12, and you have an unknown. So from this angle, your opposite over adjacent, your opposite is unknown. So, opposite over adjacent. Let's see, opposite over adjacent, that's tangent, perfect. So what we have is tangent 36. So tangent of this is opposite over adjacent. Tangent 36 equals x over 12. Well, now I have to solve this. So I multiply both sides by 12. And what I get is 12 tangent 36 equals x. Well, perfect. And here you go. How did we solve that one? The first thing you want to do is you want to go to mode, and you want to make sure you're on degree right there. If that's degree, you're good to go. If it's radian, you're not good to go, and things are going to end up pretty difficult. So let's go back to the start, and all we have to do is input 12 times tangent 36, and and we will find out what x is. So 12 times the tangent of 36, 8.71. So 8.718. So we'll say x equals 8.72. So that's how we use a calculator. That's how we use tangent in a calculator to find the length of this side length. All right, let's do one more. Let's say we have x, 15, and 42 degrees. Well, if we're starting at this angle, it looks like we're doing opposite over adjacent again. Opposite over adjacent. So tangent of any angle is opposite over adjacent. So we're doing tangent of 42 equals opposite, which is 15 over x. Okay. Oh, a little bit different because here we're going to get this independent. We have to multiply by x. So you have x times tangent 42 equals 15. Well, I need to get the x by itself, so I need to divide both sides by tangent 42. And now I put that into my calculator because now I have my x by itself because those cancel out. So I have x equals 15 divided by tangent 42. So (15) divided by tangent 42. And what I get is x equals 60. Oops. X equals 16.66. X equals 16.66. So I have 16.659. 9 rounds up to 5 to 6. So the side length is 16.66. There you go. Now you will be able to solve all your problems. For the likes of number 8, let's check out number 8 because you have some word problems on here. Number 8, an environmentalist walks to measure the width of a river. It's monitoring of a river to monitor its erosion. From point A, here's point A, she walks 100 feet downstream. From there, she measures the angle from this point to point C, which is 40 degrees. So how do I do it? Well, let's do opposite because that's what I'm trying to find, right? I'm trying to find this one. So opposite over adjacent. So that would be a tangent 40 equals opposite over adjacent. So then we take this over here. So we multiply both sides by 100. So we now have 100 times tangent 40 equals x. So 100 times tangent 40 And we get 83.9. There it is. That's the distance across the river, is 83.9. All right. Have fun with your homework. And please let me know if you have any questions.